This video is on solving two-step equations. Solving a two-step equation involves both addition or subtraction and multiplication or division. Here are some examples of two-step equations. We have 3x plus 2 is equal to 11, x divided by 4 minus 2 is equal to 9, and the quantity x plus 5 divided by 2 equals negative 6. The challenge in solving a two-step equation is figuring out which of the inverse operations to do first. Here's kind of the rule. You want to use the order of operations backwards, or undo in reverse order whatever was done to the variable. Let's take a look at an example here. So for the first equation, 3x plus 2 equals 11, notice that x is being multiplied by 3, and then it is having 2 added to it. So to get x all by itself, we want to undo each one of these in reverse order. So since we adding 2 was the last thing we did, I want to undo that by subtracting 2. So that's going to be my first step. Then x was being multiplied by 3, so I want to undo that by dividing both sides by 3. Here's what it's going to look like if I were to go to solve this. So since adding 2 was the last thing done, that's the first thing I want to undo. So to undo adding 2, I'm going to add 2. And negative 2 plus 2 gives me a 0, so I don't have to worry about those. So 3x is equal to 9. And now x is being multiplied by 3, so I want to divide it by 3. So x is equal to 3. And I can check that by plugging it back into my original equation. Put that 3 in for x, so is 3 times 3 plus 2. Is that equal to 11? Now just do order of operations on the left side of the equal sign. 3 times 3 is 9 plus 2. Is that equal to 11? Indeed it is. Our answer checks, so x is equal to 3. So remember, you want to undo whatever was done to x in reverse order using your inverse operations. So let's take a look at several examples here, and we're going to check our solutions. The first one is negative x plus 3 is equal to 21. So notice that x is being multiplied by negative 6, and then it's having 3 added to it. So undoing those backwards, I'm going to want to subtract 3 first on both sides. And remember, what you do to one side, you have to do to the other. Positive 3 minus 3 is 0. So that leaves me with a negative 6x to the left of the equal sign. And then 21 minus 3 is 18. And now I have a one-step equation. X is being multiplied by negative 6. So to undo that, I want to divide by negative 6. So x is equal to negative 3. And let's go ahead and check that by plugging that back into our original equation. Is negative 6 times negative 3 plus 3, is that equal to 21? Negative 6 times negative 3 is 18 plus 3. Is that equal to 21? Indeed it is. So my solution checks, so x is equal to negative 3. Let's take a look at our next example here, which was one of my examples up above. X divided by 4 minus 2 is equal to 9. So let's take a look at what's happening to x. X is being divided by 4, and then it's having 2 subtracted from it. So undoing those in reverse order, I'm going to undo the subtracting of 2 by adding 2 to both sides. So negative 2 plus 2 is 0. So that leaves me with x divided by 4 is equal to 9 plus 2, which is 11. So now x is being divided by 4, so I want to multiply both sides by 4. So 4 over 1 times x over 4. My 4's cancel out, they basically make a 1. So I have x equals 11 times 4, which is 44. So let's check that. Putting 44 in for x is 44 divided by 4 minus 2 equal to 9. Now, one thing I didn't say above is we don't want to act as though we're solving this equation. We basically just want to use order of operations on each side of the equal sign if necessary. So I don't want to add 2 to both sides here. I want to just kind of use PEMDAS on this. So using order of operations, 44 divided by 4 is 11. And 11 minus 2 is indeed equal to 9. So my solution of 44 checks. And my last example here says x plus 5, the whole expression divided by 2 is equal to negative 6. So what's happening to x? X is having 5 added to it, and then it's being divided by 2. So undo those backwards. So we need to undo divide by 2 first by multiplying both sides by 2. You might even want to write this as 2 over 1, because then these 2's, a 2 in the numerator, 2 in the denominator, make a 1. And that leaves me with x plus 5 is equal to negative 6 times 2, which is negative 12. And now x is having 5 added to it, so to undo adding 5, I need to subtract 5. So x is equal to a negative 17. And let's go ahead and check that by plugging negative 17 back into the original equation for x. So is negative 17 plus 5, the whole thing divided by 2, equal to negative 6. Let's use order of operations over here. Negative 17 plus 5 is negative 12, divided by 2. Is that equal to negative 6? Indeed it is. Negative 6 is equal to negative 6. So my solution is x equals negative 17. So in this video we took a look at how to solve a two-step equation. It can be a little tricky because you're going to have to use addition or subtraction and multiplication or division, and the challenge is to figure out which one of those to do first. So remember, we're basically using order of operations backwards. We're undoing in reverse order whatever was done to x.